So hello everyone, welcome to EEEE session number 1 online for module number 2 AC circuits. So we are referring June 2023 ESE paper. So let us start solving. So question number 2 is from AC circuits. So question number 1 second part is from AC circuits. So let's try to solve that. So what is the question? A circuit consists of three branches. The branch currents are, so let us write down what are the branch currents. I1 is, you can also write along with me, equal to yeah, I1 is equal to 20. Let me just open this document again once more. I1 is 20 sine of omega t plus 60 degree. Twenty sine omega t plus 60 degrees. Okay, I2 is 10 sine omega t. Let me add over here. I2 is 10 sine omega t and I3 is 75 sine omega t minus 30 degree. Okay, hello, understood? Find the resultant current. Okay, so there are three, the circuit elements consist of three parallel branches, so that means, and each branch currents are, that means there is this circuit element and you have three parallel branches. I don't know what is the element right now, like this, and you have been supplied with a supply frequency of 50 hertz. Okay, that is what is asked, right? Find the resultant current. If the supply frequency is 50 hertz, calculate the resultant current at t equal to 0 seconds. Okay, first of all you have to find the resultant current. So let's say this branch 1 has a current I1 flowing through it, I1, I2, I3. Okay, this is some elements, it is of Z, some impedance which I am writing. They are in parallel. So can you tell me what will be the total current now? I, in a parallel network current gets splits up, right? So what is I? Resultant current I. Can you tell me? Come on, try at least. Current I is I1 plus I2 plus I3. Yes or no? Hello? Can you hear me? Are you following what I'm saying? Is it making any sense? Okay, fine, fine. So I just wanted to a little feedback from you all. So resultant current will be I1 plus I2 plus I3. This you agreed upon. Now, this is a standard form. I1, I2 and I3, they are in standard form. So what is the standard form? Standard form is current is Im sine omega t plus minus phi. Some Im is the amplitude of the current. This phi is the phase angle. So either it is plus or minus. Now what we need to do is we need to convert this standard form into its polar, into its rectangular form. Yes or no? because we cannot add it like this. We cannot add them in the standard form. So how will you convert into rectangular form? How will you convert this into rectangular form? So let me give an example. So I1 is given as 20 sine omega t plus 60 degree. Okay. So rectangular form can be written as I1 is, oh, we can have to convert into polar first, sorry. So polar form can be written as the magnitude of it, the RMS value of it. This is IM. I want I RMS value. So what's the relation between IM and RMS value? Root 2 into IM, right? Or IM by root 2. There are two possible. Yes, it's IM by root 2. IM by root 2. IM is root 2 times RMS. So this requires IRMS, I1 RMS, and at an angle phi. This is the polar form. This is the standard form. This is the polar form. So phi we know already. Phi 1 we know already. It is 60. But I1 RMS is what? 20 divided by root 2. How much it is? Can you tell me? Quickly tell me. 14.14. So I1 in polar form is 14.14 angle 60 degree. Agree? Amperes. Yes or no? So this is in polar form. Now we have to convert this into rectangular form. Then only we can add. So what you will do is, in your calculator, press shift rec. There is a button, shift, press that and press rec, rectangular. Shift rec and enter the quantity 14.14 comma 60 degree comma 60, and whatever value you get, you let me know. I'll write it down here. Plus I or j, plus or minus now? 12.25 j, right? J or I, whatever you call it, complex number. I'm just calling it j because it will distinguish between this current and this complex number. So this is the rectangular form which I'm interested in, because if you want to add anything, it has to be in the rectangular form. Okay, if you want to divide any quantities or multiply them, then you have to be in the polar form. So same way we have to do it for I2 and I3. So will you do it? Can we do it together now? Okay, let's start. So for I2, what you will write? I2 is, what's the value of I2? 10 sine omega sine omega t plus 0 degree. Okay, it is plus 0, right? So this is IM. What will be RMS? 10 by root 2, which is how much? 10 by root 2 is how much? 7.071, right? So how will be this in rectangular, in polar form? 7.071. Angle कितना होगा यहाँ का? 0 degree. Okay, so this is in polar form now. Now you have to convert into rectangular. Press shift rectangular, shift rec, 7.07 comma 0. तो आंसर क्या आया बताओ? 7.07 and plus j0, right? Plus 0j ampere. So this is rectangular form. Now similarly do it for I3. 75 sine omega t minus 30 degree. So quickly do it. I3, how much it is? 75 sine omega t minus 30. So compare it with the standard form. This is I3 bar I3 angle phi. So phi will be phi 3 actually will be minus 30 degree. We have to find I3 RMS. This is IM. So how will you find IRMS here? 75 by root 2. How much is that? 53.03. And angle here. So I3 will be written as 53.03 angle minus 30 degree. Now this is in polar form. Convert into rectangular form by pressing shift rec. 53.03 and minus 30. How much did you get? Minus. Minus. Okay. This is in ampere. So this is rectangular form again. Now I have to add these three quantities. See this. Number 1, number 2 and number 3. So add them together now in rectangular form. So I will be, you can add in rectangular form only. I2 plus I3, that is 7.07 plus J 12.25 plus 7.07 plus J0 plus 45.92 minus 26.51. So add all the real quantities, this one, this one and this one, and add imaginary quantities also. So I will be how much? 60.06 and plus or minus J. So it is 0 plus 12. So minus 26.51 minus 12.25. How much it is? Minus 14.26. So this is I in rectangular form. You have to convert it into polar form. अब ये rectangular form में है. Convert into polar form. तो polar form में कैसे convert करोगे? Shift POL, shift polar 60.06 comma minus 14.26. ये calculator में करो तो how much you are getting now? 61. Are you sure? Okay. Here you are getting 61.73 and angle. Okay, perfect. So this is which form it is? Polar form. अगर मुझे वापस ये स्टैंडर्ड फॉर्म में चाहिए तो व्हाट आई विल डू, दिस इज IRMS राइट, बराबर ना. हाउ विल आई, व्हाट इज द स्टैंडर्ड फॉर्म? IM sin ओमेगा टी प्लस माइनस फाइ. सो अभी IM चाहिए तो क्या करूँगा? √2 टाइम्स IRMS. तो इसको मल्टीप्लाई करो बाय √2. 61.73 को करो √2 से, कितना हो गया? 87.3 is fine. So I will be 87.3. Okay, sine of ओमेगा टी प्लस आएगा या माइनस आएगा? माइनस 13.36. तो ये तुम्हारा आंसर है फाइनल. समझ में आया? सो सी हाउ वी व्हाट वी डिड. यू हैव अंडरस्टूड? This is the final form. Okay, so if you encounter such kind of a numerical, you cannot add them together like this only, right? So first we converted into polar, then rectangular, then we added them in rectangular, then we converted into polar and then into standard form. ये इसको बोलते हैं standard form. Okay, and that's the correct answer. Understood how to do such numericals? And now it's not over yet. Calculate the resultant current. So this is the resultant current, of course. Resultant current. Now you need to, if the supply frequency is 50 Hertz, calculate the resultant current at t equal to 0. So how will you find resultant current I now at t equal to 0? बताओ. Tell me, wherever t is there, substitute 0. So it will be 87.3 sine of 0 minus 13.36. Yes or no? So S equal to at t equal to 0. Calculate this. 87.3 sine of minus 13.36 degrees. कितना है आंसर? How much is the answer? Minus something आएगा, minus आएगा. Perfect. So this is your answer. यही आंसर है. This is what was asked. Okay? Clear हो गया how to solve this? Everyone got same answer? Minus 20.172. Yeah? You need to ask me anything, you can ask right now, or else move on to the next one. I will go to the next numerical now. Do you have any questions for me? Or you have not understood something, you can ask right now. Whatever is there inside the green color and yellow color, that is the correct answers. Understood this? Can we move on to the next one? So all the questions, numericals related to module number 2 from this paper, we will solve it today. Is this clear to you? Question number 2. Can we go to the next one now? Hello? Alright, we'll go to the next one. So this is question number 1, problem number 4. So let's read what it is. Each phase of a 3-phase delta connected load has an impedance Z phase equal to 50 angle 60 ohms, 60 degree ohms. The line voltage is 400 volts. Calculate the total power. Okay. First of all, this is your question. Then, what will be the reading of a 2 wattmeters connected to measure the power? So, ये कौन सा numerical है? Power measurement in a 3-phase circuit using 2 wattmeter method. वो वाला numerical है. Okay. So, इसका भी solution is very straightforward. Let us write down the given data. 3-phase delta connected load. So, do you know how does the delta connected load look like? Yeah. I mean, they have not asked us to draw, just for the curiosity I'm asking. Delta connected load look like this. Just for your information, I need not. Okay. This is my delta phase R, Y, B. ये है. Okay. These are the 3 phase. R, Y, B. And what is given to you? Z phase. But the impedance of each phase is given to you as 50 angle कितना था? 60 degrees. So write down the given data. And line voltage is 400 volts. VL in a 3-phase circuit is 400 volts. Alright. And it is a delta. 3-phase डेल्टा, इफ इट इज अ डेल्टा कनेक्टेड लोड मतलब डेल्टा कनेक्टेड सप्लाई भी रहेगा. अच्छा, so it's a balanced load because Z phase is same for all. Calculate the total power. What will be the reading of the two wattmeters connected to measure the power? So first of all, two questions है. Power पूछा, active power in a three phase circuit. Secondly, अगर दो wattmeter लगाओगे तो we have to find W1 W2. I hope you know what is a two wattmeter method. If no, please refer them, read that topic. It's a very important one. Either a numerical or the theory topic is always asked on two wattmeter method in three phase circuits. And three phase is not very hard. It's not at all hard. It's very simple. So can we start now, everyone? Let's say we have a three phase over here system. Okay, we have three phase system R, Y, B. We connect them together. Alright, now here in this circuit, let us start with a solution. So if you understand the question, then you will can answer the question properly. Okay. Uh, in a delta connected load, in a delta connected system, so write down point number one. In a delta connected load or a system, phase voltage is equal to line voltage, which is equal to 400 volts. Okay, are you understanding? See, this is my phase voltage, ye wala. This is phase voltage, and this is my line voltage. Both are in parallel, both are same. These are Z phase, and this is my current I phase. Now I can say now next step में my I phase will be given by V phase upon Z phase. Actually V is equal to I into R होता है ना in DC circuits. In AC circuits we have V is equal to I into Z, especially in three phase. So I will be V by Z, correct? So this is the same formula. So what is the value of VZ? What is the value of VZ? Sorry, V phase 400, right? And Z phase is how much? 50 given, no? How much it is given? 50. Magnitude is 50. It is 50 here. Alright. So how much is this? 400 divided by 50. 8 amperes are you getting? Because Z phase is in this form. Z phase angle phi. So in this case it is 50 angle 60, no? So phi is in 60 degree and Z phase magnitude is 50. So I phase mila hai 8 amperes. Are you getting it? Are you with me? Just reply. Hello. Okay. Are you writing along with me? Okay. So in a delta connected system, line voltage and phase voltage are same, but line current and phase current is not same. Now we got the value of I phase. Now we calculate IL, line current, which is root 3 times phase current, which is root 3 into 8. Can you tell me this answer? 8 into root 3, how much it is? Three phase का angle I didn't get. Okay, I understood. ये देखो everyone, phase voltages in a three phase network they are having an angle and they are 120 degree apart. Okay, तीन phase है मेरे R, Y, B. So all of them are 120 degree apart. उनका magnitude same है. Angle is 120 degree. Are you understanding? Hello? So they are equal in magnitude. So हम लोग magnitude लिख रहे हैं. We are dividing magnitude by magnitude. So V phase is 400 and Z face is 50. We are only considering the magnitude here because we want magnitude. When we want the angle, angle is 560 degree given to you. So what was your question, or am I answered your question? Okay. So can you tell me this now? How much it is? 8 into root 3. What is this number? So 13.856. So 13.86 amperes. Line current मिल गया. Why I am finding this, I'll let you know. Because power. So power in a three phase system is given by root 3 VL IL cos phi L. Okay, cos phi. VL IL cos phi. So power in a three phase network is root 3. VL कितना था 400. IL कितना है अभी 13.86 and cos of phi. Phi किधर गया 60 degree. So calculate this number. It will be a huge number. Write it in watts. So 400 into 13.86 into root 3 into cos of 60 degree. How much it is? Could you tell me this answer? This is active power consumed. So if it is greater than 100, then we don't consider point. Now it is 1000. So 408 is fine. Watts. Or you can write it as 4.8 kilowatt. Yes, both are correct. Are you following? Yes or no? Now, total power. This is the total power. Now, we'll go to the next question. What will be the reading of the two wattmeters connected to measure the power? Okay. So we need to find the readings. So how will you find now? Tell me. Matlab, they are asking us W1 and W2. Do you remember what is the power formula for in terms of in two wattmeter method? Power will be given by addition of two wattmeters. Yes or no? And this is 4001 watts. Let us call this equation number 1. Do you agree? Power in a three-phase system when using two wattmeter method is addition of the two wattmeter readings. So power is given by W1 plus W2. There is one more formula tan phi, which is root 3 into W1 minus W2. We are assuming W1 is greater than W2 divided by W1 plus W2. Okay, so here we are assuming W1 is greater than W2. Okay, and now we substitute the values. Tan phi, what is tan phi? Phi is given to you, right? How much is tan phi? Hello? Tan of, what is the angle? Phi is 60. How much is tan 60 degree? Tell me fast. And this W1 plus W2 you can replace it with 404801. Now you have to calculate W1 minus W2, right? So what is W1 minus W2? 4801 into tan 60 degree divided by root 3. How much is the answer? What is tan 60 degree? Anyone knows? What is tan 60? Come on. You have calculators with you. Tan 60 is root 3, right? Are you yes or no? So this will be into root 3 or divided by root 3. Well, this will get cancelled. So you're getting 4801 watts. Call this equation number 2. So we have equation number 1 where W1 plus W2 is 4801. So let's add 1 and 2. 1 plus 2. W1 plus W2 was 4801 and W1 minus W2 is 4801. Okay. Now what do? We add them together. So this becomes twice W1. This disappears. And this becomes twice, right? So how much is 4801 plus 4801? 96. है So W1 will be 9602 divided by 2 टाइम आया ना 4801. Yes or no? Now W1 plus W2 is how much? 4801 watts. Now W1 itself is 4801 watts. So W2 कितना रहना चाहिए अभी बताओ? Yes, 0 is the correct answer. So W2 should be 0 watt. Sorry, W2 should be 0. W1 is entire reading. It will read 4801 watts. Okay. Got the answer? So this is your answer to the question. What was the reading of the what will be the reading of the two wattmeters connected to measure the power? So the reading of the two wattmeters. Alright. Can we move on to the next one? You have any queries? You can ask now. Now we have to go to question number 3 now. Because question number 2 is all based on DC circuits. We are only solving AC circuits. Can I start this? Yeah. So current of 6 amperes flows through a non-inductive resistance in series with a coil when supplied at 230 volts 50 Hz. If the voltage across the resistance is 120 and the coil is 180, determine the total power dissipated in the circuit. Draw the complete phasor diagram. Alright, so are we ready to start now? Everyone ready? Completed with the old numericals? Yes or no? Can I start this? See, I'll tell you how many numericals are pending today. One will solve this. I'll tick mark whatever I've solved so far. So here we have solved this one, this one. What am I proposing to solve next? This one and this one. Rest all are theory questions which you can answer them better than what I can teach you. Okay, so let me I think 1 2 3 4. So 4 numericals you have to solve and that's it for today then. Okay, next time we'll solve another paper then. So can we start with this? a 6 amperes current flows through a non-inductive resistance in series with a coil when supplied at 230 volts 50 hertz. If the voltage across the resistance is 120 and across the coil is 180, determine the total power absorbed and draw the complete phasor diagram. So let's try this out. It is for 10 marks. No problem. Okay, what is the given data will you write? Let's solve this. This is question number 3 1. Yeah. What is given to you? Supply. So this is RMS value. Huh? Yeah, please write down the data. 230 volts, frequency is 50 hertz. If the voltage across the resistance is 120, so voltage across the resistance is 120 and voltage across the inductance is 180. Okay, that is what is given now. Yeah, 120 and 180. Determine the total power dissipated in the circuit. So we need to find P total, and we have to draw the complete phasor diagram. So let us begin. Let us visualize this, how it is done. So first of all, um, we can draw the conceptual picture of it. We have R, we have small r for inductance, okay. We can add a current meter over here. Yeah, okay. So let's say this is how much? 230 volts 50 hertz AC mains. They have given that voltage across the resistor. So this is my R, L and small r, which comes with the coil. So this is basically a coil resistance. Okay. So what are they showing is, they are showing you all that this is a resistor. Okay. So what is the value of VR? 120. This is coil. So what is the current across the coil? The voltage is how much? So V coil voltage is 180. So understanding this is important. Now we have to find out the, you know, uh, remaining stuff. That is, this current flowing over here is 6 amperes. 6 amperes, right? We have given the load. Anyways, as long as you all are understanding, it's okay to use the diagram. Okay. Now, tell me, this we can call it as a coil, right? This is pure resistor and this is pure coil. So you can calculate Z coil for this. You can calculate ZR for this and then eventually merge and find out the remaining parameters. So what we have to find the total power. So for a total power we require total V, voltage is there. We need to find impedance, total impedance first. So let me start. So we have total voltage, this is V. Total current is over here, I. And total impedance is all this. So tell me how to start. Yeah, solution. Okay, tell me how to solve this further. So can I say total V, total supply voltage is I into total Z. See this and this, if I combine, I'll get Z. Okay, so I into Z. Like the way we write V is equal to IR. So here it is V is equal to IZ, where Z is ZR plus Z coil. Yes or no? So what we need to do is we need to find Z, total Z of the circuit. So how to do it? First step is V is equal to I into R. Okay, and I, that resistance is Z over here, Z. Secondly, we can find the Z total of the balance delta network will be uh, so Z will be V by I, that will be 230 comma divided by the current is 6 amperes. So how much is that? 38.33 ohms. Okay, similarly we have to find the Z coil. See, the current will remain the same, the voltage will change. So let's say V across the coil will be given by I into X. Okay, so how will you find this? V coil is given to you, right? So we current will be remaining the same, so we can find the impedance. So this will be I into Z coil. ये total Z था. This is Z coil. So that is not known to you. We have to find the value of what now? Z coil. So how will you find Z coil? Z coil is V coil, which is 180 volt divided by current flowing, right? So what I'm saying is Z coil is given by V by Z. Okay, so this is V coil given to you, so I'm asking you to calculate. Oh sorry, Z coil is given by V by I coil. Okay, which is 8 only throughout because it's a series network. So now we can say V coil voltage coil is given to you. Sorry, how much is voltage across the coil? 180. And how much is the current flowing through the coil? 6. So how much will be Z coil? 180 divided by 6, 30 ohms, right? Now tell me what will be the total impedance. Total impedance is now this, we have total R, small r, and we have inductance. So iska impedance is ZR, this impedance is Z coil. So total impedance is ZT. How much is that? We know that value, right? Here it is 38.33. But ZT will be given by what? This is R, small r, and this is L. So how do you write it? ZT square, square root of, or we can call it ZT square will be how much? R value is given to you? No, no. Come on, tell me. We can find R, small r. टोटल पावर चाहिए ना. सी अच्छा चलो ये इसके पहले व्हाट इज द टोटल पावर गिवन बाय, चलो ये बताओ. आई स्क्वायर इंटू टोटल आर ना. So total current is how much given to you ना. So हम लोग को total R चाहिए. That means we required a value of small r, capital R and L. Correct? So that is what we are finding. See in the numerical what they ask you, why we are finding, the other reason we are finding is we have to draw the phasor diagram. Find the total power dissipation of the circuit and draw the complete phasor diagram. For complete phasor diagram we should have the values at least na, of R, capital R, small r and L, right? हाँ. अभी कैपिटल R का वैल्यू बताओ कितना आ रहा है. अच्छा, ZT square will keep it aside. How will you find capital R? नहीं नहीं, we have a voltage also ना, VR voltage. हाँ, so VR will be I into R. Correct na? I into R na, I total current. So R will be what? VR upon I. So VR is 120 divided by I is 6. How much it is? 20 ohms. हाँ बराबर ना. Okay. So now tell me how to proceed forward. So now I want to find the unknown value of small r and capital L. तो कैसे find करूँगा मैं बताओ. V coil is given to you, so I'll say total ZT square is given by total R. कितना हो गया? 20 plus R, can I write? Yes or no? Plus what I can say? No, no, XL square. Yes or no? अच्छा बताओ Z coil क्या है? Z coil, Z coil square क्या होगा? R square plus XL square. बराबर है? Z coil we have found out, हाँ, we remember that. So ZT square which इसको open करो, A plus B the whole square is 400 plus 40R plus R square plus XL square. So ZT पता है हमें वैल्यू कितना है? हाँ 38.33, right? So 38.33 square is equal to 400 plus 40R, and what is this? Z coil square. So do we know the value of Z coil square? Yes, 30 square. Okay. Now what is the only unknown left? It is 400 plus 40R plus 30 square. Now from here calculate R. How much is R? Calculate. So it's 38.33 square minus 30 square minus 400 upon 40. कितना वैल्यू आया आंसर का? R is how much is R? Hello. Calculate this, it's not that hard. 38.33 square. Yes. 4.23 is correct. Now how will you find L, XL? 6. So from here, XL square is Z Z coil square minus R square, right? Z coil is how much? 30 square minus R square is 4.23 square. Calculate this and calculate XL. Eight eight two. Okay, 1 1. And how much is XL? Square root of that? अच्छा, this is XL square. XL कितना हुआ? We want XL 29 point something. Square root of this will be XL. Square root of 882. How much did you get? पर अभी तक इंडक्टेंस नहीं मिला. How will you find inductance now? XL is 2 pi. F is 50 hertz. So L will be XL upon 2 pi F, right? 29.7 divided by 2 pi into 50. How much is L now? Sorry, 0.0945, right? Okay, got it. Now total power बताइए. Total power is either VI sin VI cos phi or I square into total R. R total, where R total is capital R plus small r. कैपिटल आर कितना कैलकुलेट करके मिले हमें? 20 ohms. 20 ohms plus 4.23. How much it is? 24.23. So I square, I कितना है current? Did we find a value? I is given to you 6 amperes. So 6 square into 24.23. How much is the answer? Perfect. This is the answer. So this is my what is asked in a numerical. Determine the total power dissipated in the circuit. So we required the, for total power we required the value of small r and we got it. So how much it is? 872. So this is the total power dissipated. So abhi why we required a value of L, XL and all that we'll understand now. Can we find out? So no, everyone, are you listening? Can we find out Z coil in rectangular form? How we write it? R plus JXL. Agree? Agree हो कि नहीं? Yes ना? So R is 4.23 plus JXL कितना था हमारा? 29.7, right? Can you convert this into polar form now? Shift polar करो. कितना हुआ यहाँ पे? Angle. Tell me. Yes. Similarly, tell me ZT total. इसका क्या फॉर्मूला था? R plus small r plus JXL, right? So R plus R is 24.23 plus J 29.7. तो ये कैलकुलेट करो कितना आ रहा है ZT टोटल इम्पिडेंस. into polar form. This is ohms. Oh, 33 and 50.8 ohms. Yeah. You know why I required this to calculate to draw the phasor diagram. You remember you have a phasor diagram, right? RL का phasor diagram है ना तुम लोग को. So do you know how to draw the phasor diagram now? Yes. Tell me, in an RL circuit, ये RL है ना, तो current is lagging the voltage or current is leading the voltage? Total current. So अगर current मैं ऐसे बनाता हूँ, तो voltage will be leading, right? And the angle between them is phi. अगर pure RL होता circuit, pure L circuit होता, pure L, तो it would have been ऐसे ना. This is pure L. This is RL. अभी हमारा RV आ रहा है, छोटा RV आ रहा है. So that's what we need to take care of. Okay, how do we start with? We'll draw. Oh, this is current I. We'll draw current. Now, voltage को कैसे add करोगे? What is the total voltage? Tell me. VR plus V coil, right? और phase angle कितना हो गया उसका? हाँ. So देखो तुम्हारे पास कैसे है? You have total V, which is VR and V coil. You have total Z, which is ZR plus Z coil. You have everything, all the values are available to you, right? So what was I VR plus V coil? That is I into Z. This will be I into ZR. This will be I into Z coil. Agree or no? So इनका ये वेक्टर सम होगा ना फिर करंट का. This is because we have angle also na involved in this. See, ZT is how much angle is involved. So we cannot add 38 plus Z coil as 30. No, we have to add in angle form also. Are you understanding? Yes or no? So how will you start? What will be first? Total voltage is how much given to you? 230 volts. Total voltage is 230 volts. So this 230, if V is VR plus V coil, then 230 should be equal to 120 plus 180. ना ऐसे नहीं हो रहा है ना, हाँ कि नहीं? So V vector form है, वो vector है. This is 230. How will you add? हाँ पूछो. हाँ नहीं, ये सिंगल फेज सर्किट है. This is single phase. We can root 3 VL cos phi, we can do it for 3 phase circuits. Are you get? हाँ, yeah, you have the formula for power as VI cos phi. You can use this. So how much is V? Let's do that. V is 230. Current कितना है तुम्हारा 6 and phi कितना है सर्किट में? phi, what is the value of phi? Z वाला Z phi, ये 50.8. So cos of 50.8 करो, you'll get the same answer. You should get the same answer. Same answer आया कि नहीं? So both the formulas are there, you can use both of them. नो प्रॉब्लम ओके. वो जो तुम बोल रहे हो रूट थ्री वी एल आई एल वो थ्री फेज सर्किट के लिए, ये सिंगल फेज सर्किट है. अंडरस्टूड नाउ. व्हाट आई एम ट्राइंग टू से इज अभी हम लोग फेजर डायग्राम बना रहे हो, तो फेजर डायग्राम में टोटल वी इज वी आर प्लस वी कॉल होना चाहिए, बट इट इज नॉट बिकॉज वो वेक्टर सम है. वेक्टर ऐड कर रहे हो, वेक्टर. हाँ अभी बताओ करोगे कैसे ये, हाउ विल यू ऐड देम टुगेदर. तो पहले तो हम लोग आर एल का बनाते हैं, ये आर एल, ये आर और ये एल का. देन विल ड्रॉ इट फॉर दिस आर. सो हाउ विल यू नो टोटल आई एंड टोटल वी के अक्रॉस कैसे बनाओगे वोल्टेजेस, बताओ. बताइए आप लोग कैसे स्टार्ट करोगे हमें. सी वी हैव आर, वी हैव स्मॉल आर एंड कॉइल, ऐसे है ये एल है, ये आर है. ओके. देन वी हैव वोल्टेज अक्रॉस आर, वोल्टेज अक्रॉस दिस कॉइल, टोटल कॉइल. सो ये कॉइल का पहले बनाना है ना, हाउ विल इट करेक्ट. तो अब ये बताया था ना ऐसे इधर आएगा ये वी कॉइल एंड ऑल दैट. सो हाउ विल यू स्टार्ट. लेट्स ड्रॉ, कम ऑन हेल्प मी आउट. सी देखो वी कॉइल वोल्टेज किधर आएगा, वी आर. अच्छा वी आर किधर आएगा बताओ, वी आर पैरेलल ना. अरे बोलो ना वी आर, यस और नो स्टूडेंट्स. हाँ वी आर. और वी ऑफ स्मॉल आर किधर आएगा, वी कॉइल इज हाउ मच, वी कॉइल is VR plus VL. So where will V coil come? अच्छा ये RL सर्किट, पहले इसका बनाते हैं ब्रेकअप. For RL circuit, how will the phasor diagram come? Is this is I. So this will be VR. Correct? V small r. Now, how will you draw, VL? बताइए. I'll show you one example. मैं एग्जाम्पल बताता हूँ वेक्टर सम का. लेट मी शो इट टू यू इफ इट इज देयर हियर. ये RC सीरीज है ना, not an RL. I want RL. I'll show you one example where I have taken similar kind of a numerical. Let me see if the numerical is there or no. I think it's there. I have solved similar numerical in the class. देखो ये RLC है ना, but we don't want RLC. ये देखो ऐसे रहेगा ना, VL V. There was one diagram. We'll come back to it later, I guess. ये phasor diagram हम लोग वापस आते हैं. We'll draw it at the end. We'll come back to it later. We'll go ahead with other numericals. We'll definitely come back to it. Let us go to the next numerical till then. Phasor diagram में बताता हूँ तुम्हें वापस. Okay. Let's go to the next numerical now. A series RLC circuit has following parameters. R, L and C value दिए हुए हैं. Okay, can you see that? RLC values. R is 10 ohm. We can write it down. Let's see. It's a series RLC circuit. So let me start writing over here. We'll come back to this phasor diagram. Give me some time. We will sort it out. Okay. So next numerical is numerical number question number 3 and second part. Okay. So we have a series RLC. I think it's a numerical on resonance. So yeah, resonance hai. So it's a series RLC resonance. So what is given? R is given as how much? 10 ohms. L is given as 0.014 Henry and C is given as 100 microfarad. Compute the following quality factor of the circuit. So we need to find quality factor Q. Okay, then bandwidth, then lower and upper frequency points, meaning we have to find omega 1 and omega 2, or we have to find f1 and f2, whatever case you want to find it, bandwidth. Then we have to find the maximum value of the voltage appearing across the capacitor. So we have to find voltage across the capacitor maximum, so VC max. Okay, so it looks like a quite challenging numerical. It's for 10 marks. So voltage across the capacitor, if the V of t is given by, so we likhne do, V of t is how much? V of t is given as 1 sine 1000 t. So if this voltage is appearing, then what is the value of maximum value appearing across the capacitor? Did you understand the numerical now? It's a series RLC resonance because we have to find the bandwidth, quality factor. So can we start here, everyone? Okay. So first we have to find the cutoff frequency, the resonant frequency. So what is resonant frequency given by? Hello? Two formulas. F naught is 1 upon 2 pi square root of L by C, or we can find omega naught, which is 1 upon square root of LC. So we can find this will be in hertz, this will be in radians per second. So let's find in omega naught because it's easier. 1 upon square root of L, 0.014 into 100 microfarad. Tell me this answer quickly. How much it is in radians per second? Come on. Hello, can you tell me the answer now? Omega naught is how much? Zero point 0.014 into 100 microfarad. Come on, we have AC circuits numericals left. 8.45. No, -4 नहीं आता, गलत कर रहे हो. 1 divided by square root of 0.014 into 100 microfarad. तो इसका माइक्रो में थोड़ी आएगा, मिली में भी नहीं आएगा. It must be 845. I am getting this answer. Check. 845.15 radians per second I'm getting. Okay, is anyone getting this value? Okay. Next is quality factor Q is given by the formula 1 upon R square root of L by C. So 1 upon R is how much? R is 10 ohms. Square root of L is 0.014. Acha, C is 100 microfarad. Calculate quality factor now. How much it is? Straightforward substitution in calculator, that's it. So you can easily tell this value. How much? Come on quickly, we have to solve more numericals. How much is the quality factor? Put the units properly, okay? Is it 1 point something, 1.18? Okay. Next, find out bandwidth. What is bandwidth? R by L in radians per second, huh? Or it will be R by 2 pi L in frequency. So this is 10 divided by 0.014. That will be 714.28 radians per second. Check this answer. Now fourth, how will you find upper and lower points? What we have to find now next? Upper and lower frequency points. So there is two formulas given over there, which is lower frequency omega 1, which is omega naught minus R by 2L. Calculate this. Omega naught is how much? 845.15. 845.15 minus R divided by 2 into L. So omega 1 you calculate, then higher frequency will be omega 2, omega naught plus R by 2L. How is omega 1? How much it is? Is it 488? This is 445.15 plus 10 into 2 into 0.014. So omega 2 is how much? Is it 1200? Yes or no? Okay, very good. Now remember, it's a series RLC resonance circuit, okay? Now we'll go to the third part, which is very crucial. What they are saying is we have a R, L and a C, okay? And they have given this value. This is 1 sine of 1000t. And they are asking us what is the maximum value across C. Okay, now the current flowing through the circuit might be I. Okay, this is VR and this is VL. Alright, now let's write this down. Voltage across the circuit is given by V is equal to 1 sine 1000t. What is the standard form? Vm sine omega t, plus or minus phi. Phi is not there, so phi is 0. So what is Vm over here? 1 volt. What is omega? How much is omega? 1000 now. Yes or no? Now tell me how much is XC. 1 upon omega c, right? So it is 1000 into 100 microfarad. So tell me what is the answer XC? Is it 10? XL is omega L. Omega is 1000. L is 0. How much it is? 014. So is it 14 ohms? ये check करो values आ रहे क्या नहीं? 10 and 14. Why I am saying this? Because कौन सा बड़ा है बताओ? XC बड़ा है, XL बड़ा है? XL is greater than XC, right? So it's a inductive circuit. So अगर इंडक्टिव सर्किट है, टोटल Z मेरा कितना होता है RLC सर्किट में? R plus JX, where X is XL minus XC. Okay? So total R कितना है मेरा? R is 10 plus J XL minus XC कितना हो गया? This is 14 minus 10. How much it is? 4 ohms plus J 4 ohms. बराबर है? Yes or no? Now total V in RMS कितना है? VM दिया है ना, VM. So VM by root 2, that is 1 by root 2. So V RMS कितना हो गया मेरे पास? 1 by root 2 is 0.707. Is it not? Hello, are you listening? So what is total V given by? Total V is I into Z, but ये I कौन सा होना चाहिए? RMS value. So now we'll say total I will be given by V by Z total. So V is how much? How much is V? 0. in polar form कैसे लिखोगे V को? V RMS value 0.707 angle 0 degree. So 707 angle 0 degree. What is ZT? इसको पोलर फॉर्म में कन्वर्ट करो प्लीज. 10 plus J4. What is the polar form of it? Shift polar 10, 4. How much it is? How much is this? 21.80. So यही आएगा इधर 10.77 21.80. ओके, तो क्या हो गया इसका बताओ? करंट इन वेक्टर फॉर्म में कितना हो गया? 0.707 डिवाइडेड बाय 10.77 कितना हो गया वैल्यू? How much is the value over here? It's very small. 0.0656, is it? And angle is minus 28, 21 point. This is the current. Now tell me, अभी voltage maximum voltage का भी निकाले VC. VC will be what? You tell me now. VC will be I into XC. Yes or no? VL is I into XL. लिखा था ना ये? VR is I into R. So VC will be I into XC. I का मैग्नीट्यूड कितना है? इतना 0.0656. What is XC? Oh, this is RMS value ना? IRMS. तो मैक्सिमम वैल्यू चाहिए तो IM आएगा. IM तो IM कैसे कैलकुलेट करते हो इन टर्म्स ऑफ RMS? IRMS into root 2, correct? Into XC. XC is 10, I guess, right? So calculate maximum value, VC max. कितना हुआ voltage? You can tell me this answer? 10 into 0.0656 into root 2. How much is it? 0.928. Is this the answer? Yeah, this is the answer. This is the correct answer. So yeah, I mean, you should know your concepts well to solve this kind of numericals. Okay. As you can see, you have to work, hard, so that you have practiced enough numericals so that these numericals comes naturally to you. All right. Can we go to the next one now? There are a lot of numericals on this. One more. I think two more numericals are left. Then we are done for today. Three phase wala and one is series RLC again. Can I start with another next numerical now? Is this complete? The answers are all correct. I've cross checked it. Can we go for the next one? Next one is three phase wala. A 450 volt, 50 hertz, three phase voltage is applied to a three phase star connected identical impedance, each consisting of resistance 15 ohm, capacitance 177 microfarad, and inductance 0.1 Henry in series. Find, don't worry about it at all, it's very simple. Find phase current, line current, power drawn, power factor, reactive power, total KVA, and draw the phasor diagram. Phasor diagram will do it, some other time. Maybe we can draw it, no problem at all. Phasor diagram will do it. And will first of all you have to solve the numerical. So can we start? Yeah. I'll keep this numerical over here and write down the given data one by one. Okay, help me out in this. 415 volt. So first of all, what do we have over here? 415 volt. This is question number 3, third part. So we have three phase star connected system where line voltage is given 415 volt, frequency is given as 50 hertz. Okay, then what they have given, applied to a three phase star connected identical impedances. So star connected system कैसे बनाते हो पता है तुम्हें? Let me draw star connected system and show it to you this way. So probably they have used this. Let me draw this way first. Then you will understand what I am doing. This is star. Oh, sorry, this is delta. So star will be like this. Sorry for that. So this is R, Y, B. Okay, R, Y, B phase. This is my load. Okay, so what they are saying is this Z phase, this each phase, let me call it as Z phase. Z phase consists of RLC. ये मेरा है R, L and C, इससे बना हुआ है. So I have to find Z phase actually. Okay, it doesn't matter what you have, RL or a resistor also. Okay, it doesn't matter. So now we have to calculate Z phase. So tell me इसका resistance कितना है? inductance कितना है, capacitance कितना है. Let me tell the value. R is 15 ohms, 177 microfarad is the value of capacitor, and this is 0.1. पहले ये लिख लेते हैं, that's it. So that is what is given to you. Now what we need to find out, I write blue in color, to find first phase current. So I phase, then line current IL, power drawn, power of three phase, power factor, reactive power is Q, total kVA is S, and the phasor diagram. So phasor diagram we might do it some other time, maybe next time, but at least the numerical will solve it. This is the given picture to you. Okay, so three phase circuits, as you can see, there are a lot of numericals on three phase circuits. So you have to do for AC circuits, three phase, single phase, everything. You cannot leave out any topic. As you can see in this paper, a lot of numericals were asked, and this is last year paper only. So yeah, so can we start, everyone? Hello, hello. Okay, so let's start. Let us begin. So write the solution. So we need to find Z phase first. So Z phase general formula is R plus minus J X. If the circuit is capacitive, then it will be R minus Jx, and X will be Xc minus XL. If it is inductive, it will be R plus Jx, where X will be XL minus Xc. So for that we need to find Xc and XL, and whichever is greater, we'll consider that inductive or capacitive. So first find out XL. 2 pi FL, 2 pi 50 into L. L is 0.1. How much is this XL? Quickly tell me. XL, come on. 100 pi into 0.1. Calculator. 31.42, correct. XC will be 1 upon 2 pi FC, which is 1 upon 2 pi into 50. C is 177 microfarad. So calculate this carefully. XC will be somewhere around 15 to 17, 18, 19 volt ohms. 70. Yeah, 17.98. That was close to 18 ohms. Yeah, correct. Now tell me which is greater. XL is greater than XC. तो formula क्या रहेगा अभी? R plus JX, where X is XL minus XC. So calculate this X, 31.42 minus 17.98. कितना हो गया इसका value? 31.42 minus 17.98. That comes out to be 13.44 ohms. So Z phase will be R plus J into XL minus XC. R is how much? R is 15 ohms plus J 13.44. Okay, convert this into polar. So write shift polar 15 comma 13.44. How much it is? Can you tell? Yeah. How much is Z phase? What? How will you do it normally? Because what I want is, I want I phase, which is Z phase upon, V phase upon Z phase. So that's why I'm converting into polar. हाँ. No, 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 don't do that. No, don't do that. डायरेक्टली अब मिल रहा है ना, तो वाई हैव टू डू स्क्वायर रूट ऑफ आर स्क्वायर प्लस एक्सएल, है ना? हाउ मच टू टेल मी द आंसर? 20 point something ohms, correct. So this is in the standard form. Which form is that? ये total z phase है. Z phase is z phase in polar at an angle of phi. ये RMS वाला है value. Okay. Now what do we do is we'll calculate V phase. So इसमें phi कितना आया हमें? 41.86. So this is the angle which we got. Now V phase in terms of VL will be VL by root 3. और VL कितना दिया है? 415 divided by root 3. How much is that? How much is V phase? Volts. Alright. Now I phase will be, next we have to find out phase current. Huh? So I phase will be V phase divided by Z phase. V phase is 239. Oh, degree नहीं है यहाँ पे. 239.6 divided by Z phase is how much? 20.14. How much is this? Calculate. Now did you understand? We are taking directly the magnitude. How much is I phase? एंगल नहीं है इसमें करना है. थ्री फेज है ना, एंगल मत लिखो इसमें. एंड फॉर अ सीरीज star connected delta network, IL is same as I phase. So line current is same as phase current, which is 11.89. Next will be power. Power in three phase. क्या formula है? Root 3 VL IL cos phi. So root 3 VL is 415, IL is 11.89, and cos of which angle I will take? Z phase वाला 41.86. So tell me this number. Power in three phase will be, sorry, 63. So it is 6.365 kilowatt. We can write it like this also, right? Both are correct. Now power factor कैसे find करोगे? Cos phi. So cos of 41.86. Quickly tell me this answer. It is 0. Lagging or leading? It's lagging because it's an inductive circuit. Okay. Now to calculate reactive power Q. So root 3 VL IL sin phi L. Same formula, sin phi. So it will be root 3 into 415 into 11.89 into sine of 41.86. How much is this reactive power? Unit is VAR. Okay, or 5.703 kVAR. kVAR. अभी S फाइंड करना है. Root 3 VLIL. That's it. So root 3 into 415 into 11.89. How much is that? इसका यूनिट क्या है, VA. So 8.546, right? kVA. Because it was asked in a numerical. You have to find in terms of kVA. See? Shall I show it to you? Yeah, here it is. Total kVA. Okay? And finally draw the phasor diagram. Well, the phasor diagram will require some background. I don't know how much background you all have, but still, if you want I can show it, or we can do it next time. फेजर डायग्राम बताओ मैं कैसे बनाती हूँ उसका, थ्री फेज. हाँ, स्टार कनेक्टेड सिस्टम. नहीं, टुडे ओनली. I can show it, no problem at all. For me, it's not a problem. Okay. So, in a three-phase star-connected system, we establish the relation between three phases. So, three phases है VRY, RYB है ना. So, VYB and VBR. Okay. So, VRY can be written as VRN. Okay, VRN minus VYN. Okay, VRY in terms of these are these are my phase voltage. This is my line voltage. So these three are yellow color जो कर रहा हूँ. These are all line voltages, and my phase voltages. And let me write green in color. VRN, VYN, VBN. N is the neutral point. Okay, so ये diagram में I can write the same thing as VRN plus VNY. Okay, now similarly second case में we have VYB, so it is VYN minus VBN. Okay, instead of that we can write VYN plus VNB bar. Okay, third case we have VBR is VBN minus VRN. So VBN plus VNR. This way we have, right, voltages. So we will start with line voltages or phase voltages first. Tell me. We have to start with phase voltages first. Alright? Are you listening? So phase voltages कैसे बनाओगे पहले? 180 degree, 120 degree apart. So you let me draw it. So ये मैंने बनाया सबसे पहले VRN. So 120 degree छोड़ के I have to draw VYN. VYN. Then again 120 degree I'll leave it and I'll draw. Okay, same magnitude but differing in each other by 120 degree. So this is VBN. Sorry. Okay, बनाया ये? Everyone this much understood? Then हमें इसके dotted lines बनाने पीछे. Okay, so this is VBN. How will I draw VNB? कैसे बनाऊंगा इसका dotted line? पीछे लूंगा, back side. So this is VNB. Then I'll take VNR. VNR कैसे बनाऊंगा यहाँ पे? Back side. I'll go back. Okay, so this is VNR and this is VNY. Are you getting it? उसका mirror image पीछे VNY. Alright, so remember these differ from each other by 120 degree. ये 120 degree है सब कुछ, all of them differ by 120 degree with each other. They are same in magnitude. Okay, इतना समझा है? Now what I want is I will be drawing them with the help of law of parallelogram. So अभी क्या है, VRY किधर किधर आ रहा है? VNY. Identify VNY किधर है? अच्छा, VRN plus VNY इधर आया ना ये दोनों का, दिस एंड दिस, करेक्ट. तो इनका क्या करने का, पैरेललोग्राम. द वे इट इज लुकिंग ओवर हियर, यू हैव टू ड्रॉ दिस डॉटेड लाइन ओवर हियर ऐसे, एंड ड्रॉ दिस ओवर हियर. जहाँ पे ये हो रहा है इंटरसेक्शन, there you can draw this line. Law of parallelogram back basically. Okay, यहाँ से आया. So this becomes V R Y. Understood? So this is my line voltage. These were my phase voltages. Are you understanding? Similarly, VYB. So VYB is a combination of VYN and VNB. So VYN and VNB. तो यहाँ पे आएगा somewhat. It will be somewhat across here. Here it will come. Okay. Law of parallelogram. So draw parallel lines to this and complete this. This will be V Y B. So this is another line voltage. Last line voltage you must have guessed. VBR is how much? VBN. So VBN is over here, and VNR. So इधर आएगा somewhere around close to this. Okay, visible now? Okay, here it will come. Let me open that document again for you. It's a little bit okay. I got to back to the PDF. Yeah, here it is. So this is VBR. Now it's an inductive load because power factor is lagging. So we have an inductive load. So where will you draw the currents? Current also we have to draw. Na? Current is lagging, right? So current is lagging behind the voltages in an inductive load. So where will I draw it? Behind the. So tell me, where will I draw current? So current might be over here. This is I Y current. Okay, this angle is phi. Okay, so line current makes an angle with line voltage. These are my three. Oh, sorry for that. These are my three yellow color which I marked. These are my three line volt. Sorry, not this. Sorry. These are my three line voltages. So current also I'll draw it like this. This is IR. This is phi. And here it will be here. Over here. Current is always lagging behind the voltage. Voltage is first. Okay, what way it is coming? Like this current. So IB. This angle is phi. Okay. So this completes. See, the phi is the phase angle between. Phi is the phase angle between line current and line voltage. Okay, line current and line voltage. Okay, so this is my phasor diagram. You all were listening? Understood how to draw it? It's pretty simple. No hard and fast rule. Understood this? Can I move on to the last numerical for the day? Hello students, you all are there? Okay, phasor diagram made some students disappear, but still no problem. That's why I was not solving it so much. Okay, can we start now with and complete the last numerical assigned in this okay. Here it is, question number 4, second part. In a series RLC circuit, R is equal to 10 ohms, L is equal to zero point 0.1, and the maximum current occurs at 50 hertz. After condenser is brought across the circuit such that maximum impedance occurs at 100 hertz, find the two capacitance. What is a condenser? What is a condenser? Capacitor. समझ गए हो? Yes or no? Condenser means a capacitor. So first of all, we need to find the condenser. Two capacitance कैसे हो गए? One is RLC and other is RL. Again, capacitor is in parallel with the RLC circuit. So we need to find both the capacitors. So let me draw, visualize it, and show it to you. So this is question number 4. Second part, RLC series circuit. We have R given to you, we have L given to you, and we have been said cutoff resonant frequency is 50 hertz. See, maximum current occurs at 50 hertz, so that means it's the cutoff frequency, it's the resonant frequency, sorry. And we have to find the value of C1. C, okay, RLC circuit is there. Here go, this RLC circuit. C value is not known to you, L and R is known to you. So this is 50 hertz. We don't know the magnitude of it. So first we have to find this C1. Then they are saying in the second part that now this value of C1, B part mein, you have this RLC circuit, you have this capacitor, now add another capacitor which is C2. This was C1, L and R. And why to do that? Let us see. So that the another condenser is brought across the circuit so that the maximum impedance occurs at 100 hertz. So maximum impedance will occur at current minimum. So this becomes 100 hertz. So ये parallel हो गया. पहले series था, अभी parallel है. In a parallel, impedance is maximum. In a series, current is maximum. Remember that. Okay. So this we need to find C2 over here. C1 we have found out. Let us start with this. So series parallel resonance का है, numerical है. So first circuit we have to find C1. How to find C1? Anyone? RLC series resonance का formula क्या है बताओ? F naught is 1 upon 2 pi square root of LC, right? LC1. From here can you calculate C1 directly? Yes. F naught is given 50 hertz. 1 upon square root of L is how much? 0.1 into C1. So please solve for C1 and tell me the answer. It will be in microfarad. Tell me the answer. Understood? So please let me know the answer quickly. You tell me the answer in terms of 10 raised to minus 6. तो फर्स्ट केस में क्या हो रहा है? मैक्सिमम करंट मिल रहा है, मैक्सिमम करंट. तो मैक्सिमम करंट कभी मिलता है? इन केस ऑफ सीरीज रेजोनेंस. एंड सीरीज रेजोनेंस का फॉर्मूला इज दिस. दिस इज सीरीज रेजोनेंस फॉर्मूला. Okay, let me know the value of C1. Anyone? Substitute it over here and calculate, put it in the calculator. Are you getting 100, around 100 microfarad? How much did you get? Come on students, I am also getting late. How much? 101.3? Okay, fine. So now that we got C1, now what are it saying? Current is minimum. Oh, Z impedance is maximum. So what type of circuit is this? Parallel resonance. Okay. Now and resonant is 100 hertz right now. Alright, we need to find the value of C2. So how to find the value of C2? We have to find the value of L first. Here. Oh, L is given to you, right? L is given to you. So we need to find what now? Yeah. Come on. Tell me how to figure this out. You have to find equivalent impedance of this network. So first find XL again. Now we have to find new, right? Because everything is now at 100 hertz. So XL is 2 pi FL, 2 pi into 100 into how much was L given to you? 0 0.1 Henry. This is this. And how much is this now? 101.3 microfarad. Correct? Now tell me, how much is this L? Is it 62.83 ohms? Yes or no? No. Acha, yes. XC will be 1 upon 2 pi FC1, 1 upon 2 pi into 100 into C1 is 101.3, 10 raised to minus 6. How much is XC? So what is total now? X. Which is greater? XL is greater, right? XL is greater than XC. So now XL is, calculate this X. How much it is? 47 point something, 0.12, right? तो पूरा सर्किट इंडक्टिव हो गया ना मेरा, है ना? तो दिस इज एक्सएल इक्वालेंट. एक्सएल इक्वालेंट हो गया मेरा, इक्वालेंट. So what is XL equivalent formula? बताओ. 2 pi F L equivalent. So L equivalent will be XL equivalent divided by 2 pi. Correct? 2 pi F. So that is 47.12 divided by 2 into pi into 100. How much is this? L equivalent, can you tell me? This much? So सारे components we have found out at 100 hertz. Okay. L equivalent, C equivalent, I mean XC, XL and L equivalent. Now, what is the resonant frequency at say parallel resonance का formula कितना है? Do you know the parallel resonance formula F naught? 1 upon 2 pi square root of 1 upon LC minus R square upon L square. सो ये C2 रहेगा, C2. सो इसमें से ये पता है तुम्हें, हाउ मच इज दिस इज 100 हर्ट्ज. R how much it is? 10. L कितना है न्यू वाला? 0.075. So can you calculate C? So calculate C in microfarad and tell me quickly. So 1 upon LC minus R square upon L square. So ये total L है, L equivalent है वो. How much is the answer? Let me know. 32 कुछ आता है. Okay, मिला है तुम्हें आंसर? You got the answers? Anyone with the answer? Yeah, anyone? I'm getting around 32. Anyone got nearby? 38. How much it was? Let me check. Somewhere close to it was 32 point something. Anyone got that nearby? 32.32. Did anyone got the value, nearby value to this? How much did you get? Which one? But you got the same result or no? Okay. Okay. All of you got the same answer. Rest of you all. Yes, no, what? Others. Okay. Alright. 32.4 something. You're getting it. That's great. So then, I think we have completed today's assigned numericals. Just a sec, I'm searching something. I'll tell you all when I get it. You want me to ask anything or cover anything next time? Next time also we will be doing it like this. So you all have any recommendations? Sorry, what which formula? No, no, he has taken L out. If you take L out, it will be under root of L by C2 minus R square. ऐसे आएगा बराबर ना? Yeah, yeah. So that's the case. We have left out with one numerical, वो phasor diagram वाला ना, वही मैं देख रहा हूँ कब से. I'm searching for the similar numerical. Just a few seconds more. If I didn't get it, I'll do it next time. Not Thursday. This is revision lecture. So revision lecture will go on now consecutive 3 weeks. Um, yeah, maybe Saturday. Maybe I'll let you know exact date. But it will be on holidays only, like not public holidays, the normal holidays. Tuesday I am taking it for your class, but this is there are other students also from other division, so that I'll separately inform you all. No, no, not revision lecture. It will be formal lecture.